All right, today we are doing line of best fit. It will be you will do page 199, 1 through 27 odd in the Big Ideas book. We will be looking at homework after that. So I'm going to pass. All right, so today we're looking at the line of best fit for a given set of data. Now, this is where we actually take the math and we're using it in a real life situation. So for instance, right now my niece is working in Texas at the U of T, where she runs a lab with animals. Okay, she's actually, her field of study is neuroscience, and this is, she's basically looking at patterns, and you would create an equation to describe that pattern. So if we look at this type of situation where you've got the animal, notice they are comparing the brain weight to the lifespan. Okay, the brain weight to the lifespan. And they've got some numbers here. First thing I would like to ask you is, what would you consider depends on the other? What statement do you think they're trying to make with this study? Arun?
The max life expectancy depends on the brain weight.
So he's saying your maximum life expectancy depends on your brain weight. So the maximum life dependency depends on your brain weight. So if we were to create a graph of this, what would be my depender? What is my depender? Parsa?
The max life.
The maximum lifespan. Your lifespan is the depender. So is that going to go on the X or Y axis? It's going to go on the Y axis. So I have to create a graph, and now the one thing you need to think about is, what scale are we going to do? If my lifespan is for the Y axis, then the brain weight in grams has to be for the X axis. Now when you create a line of best fit type of graph, if you don't have labels, then your graph means nothing. So you're not only graphing each line, but what does this line represent? What does this line represent? Your graph means nothing without the label. So we're going to say brain weight, and the other is maximum life. Now, your scale for the x-axis, it has to be covered from 4/10 all the way to 440. So what are we going to make our scale by? Yes. Hundreds or 50s, either one. Okay? And my maximum lifespan, they're actually doing by 50s. They just chose to write every other line. And my maximum lifespan, how am I going to do that scale? How am I going to create that scale? Ben?
5.
He's going to do by 5s. Good. So we really kind of do 10s every other one. That's really by units of 5. Because we have to make sure to include from 3 2/10 to 50. And now we're basically just going to plot the data. So I'm going to go to when x is 4/10. It's barely, when x is 4/10, not even 1, it's less than 1, so it's almost here. It's 3.3 2/10. It's less than 5, so somewhere around here. With a fox, when they're 50, I come to about here, about 50. I'm going to about 9.8, just under the 10. Do you understand how to plot that data? So I'm going to plot all those points, and then we're going to make sense of it. So what statement do you think they're trying to make? If I were doing research and I presented this as my data, what statement do you think that the developers of this survey are making? Mason?
I think they're making that you have a longer life expectancy if you have more mass in your brain.
So they're trying to say, the bigger the brain, the longer you live.
Except the seal and the donkey. The seal has a smaller brain and lives longer than the donkey.
So there are exceptions, right?
Yeah, with exceptions.
Okay, but on average, we're not looking so much at the details, and you can see in this Is this moving in a linear way? You don't think this kind of makes a line versus it being all over the place? Is it moving in a linear manner? Okay? It's not making an exact line because it's real data, but it's moving at a linear trend. We call this a linear trend. So this is a scatter plot because the data is scattered. And with real data, it's not going to be an exact pretty line. But it is, in this case, it's going in a linear trend. If it's going in a linear trend, we can try and write the equation for it. Now, we read a graph from left to right. Left to right. So is the linear trend increasing or decreasing? Yes. It's increasing because it starts low and it goes high. We read from left to right. So if it started on the left up high and goes low, then we would say it was decreasing. You should be taking notes. This is the important stuff that you are all taking notes on. Now, we say the trend is increasing. Sketch the graph. Put a few dots on it. Trend is increasing. Doesn't have to be exact and perfect. And we say that this has a linear trend. We say that this has a linear trend. Questions? Now, our line of best fit is a line that we are going to draw on here to try and create an equation. I'm trying to create an equation. Now, I've got a ruler in my hand and you can't see what I'm doing on the board, but I'm going to try and draw a line and pretend like this line is a magnet or this is metal and all the little dots are magnets, okay? The points are like magnets and this line is metal. So where would I place that line? Where would I place that line? Do I want to place it here where I'm going to attract most of the magnets or most of the points? I can try and place it. Is this the right place? I'm not going to attract most of the... I need you out of there and I need you writing notes. Okay? Is this going to be the place where I place the point? Okay? I mean, place the line. How about here? Looks pretty good. What do you think, Brandon?
Looks pretty good. I think it,
You think it could be better. Where would you place it to make it better?
I'd place it a little bit higher.
A little higher. You want to place your line of best fit basically in the middle. So you have equal amount of points below it and above it. Because you want to attract as many as possible. In this case, still not kind of going through the middle because the slope looks different. The steepness. So if I go through exactly the middle, I've got equal amounts above it, below it. Now, if you have one squirrely point out in nowhere land, we're not going to account for that. Anybody know what that's called, that squirrely point? If it was like, let's say it was 500, 5. Jay,
Isn't it an outlier?
that's our outlier. We're not going to account for that because we're looking for the rule. We're looking for a pattern. We're trying to make sense of this real life data so we can predict future quantities. Okay. So, in this situation, the first thing we're going to do, I want you to write down the steps. We're going to plot the points. Write these steps down. Plot the points. Step 2, we're going to draw the line of best fit. Now, to get the equation, what do we need? What do we always need to write an equation of a line? Vincent.
Slope and line.
I need a slope. I need a slope and I need a y-intercept. Okay? If I don't have the slope and the y-intercept, I can use something to get my slope and y-intercept. And what is that, Mason?
Well, you can find 2 points to get the slope. The
Okay.
y-intercept you can use from the standard form of what the line is.
No. Josh?
You can use a point slope.
Okay, but what I'm saying, yes, we don't need the, right now I was asking what I could use. He said you can use the point slope formula. So really what we need at this point is, as long as we have a point and the slope, we can write the equation. If I am given 2 points, I can find the slope and I can use one of the points to find the y-intercept. Okay? So you can, I've drawn a little thing up here on the board. I guess I can put it right here. Where I am, to write the linear equation, I need the line, we need a slope and the y-intercept. And if I don't have that, there's 3 ways to find that. I can find it with a slope and a point. Sorry, I'm writing with my finger. I can find it with 2 points, or our slope and our y-intercept. I mean, I can just use that. Or we can do it with 2 points. Does everybody understand that? Okay, so we're trying to write the equation of a line. Okay, so I draw the line of best fit. And so what's the first thing I'm going for here? What does every equation need?
Slope and y-intercept.
So what's the first thing I'm going to go for?
Slope.
Slope. Let's try and find our slope. And we're going to do that. Am I given the slope in a line of best fit? No? So what do you think we would do? Yes? Slope formula and? I wouldn't use rise over run for this because it's not exact. I would only do that when we have an exact line. In this one, we're going to want to use slope formula. And how am I going to do that? Given what? 2 points. 2 points. Take 2 points. Any 2 points. Now, we're going to want to pick points that are sufficiently spread apart. The closer they are together, the less accurate our line is. Now, what Griffin finds versus what Tristan finds, depending on the 2 points they take, is going to give each other, they're going to have different answers. They're not going to be exact. But you should be within the ballpark. Okay? So we take 2 points that are sufficiently spread apart. Okay? In this case, we're taking 50, 10 and 450, 50. Liam, you with me? Okay. So, what would I do next, Liam, given I'm taking those 2 points?
You simplify it and just slope formula.
We're going to use the slope formula, and that's y2 minus y1. Okay? And what am I going to subtract?
Subtract.
In the numerator?
Subtract 10.
In the numerator.
Oh, in the numerator, 450. Or
Okay, what is y2? What is y1?
y2 is 50.
y1 is?
10.
So what's it going to look like?
50 minus 10
Over?
over 450 minus 50.
Now, we clear this up by just numbering our slopes. x1, y1, x2, y2. There we go. 50 minus 10 over 450 minus 50. And what do we end up with? Elijah? What do I just simplify this? 40 over 400, which simplifies to what? Does not simplify to 10. I'm left with 4 over 40 if I just divide top and bottom by 100, by 10. So what am I left with? Just simplify it, Elijah. There's no math. What number divides into both?
4.
I mean, very little math. It's mental math. 4. 4 goes into 4 one time, and 4 goes into 40. So what is my answer? 1/10. Now, convert that to a decimal. With line of best fit, we use decimal now. What is that?
0.10.
0.1.
Yeah, 0.1.
0 and 1/10. We use 0 and 1/10. Okay. So we've got our slope, 0 and 1/10. Okay. And as soon as you take that point, notice my symbolism here. Notice I went from an equal sign to about. So as soon as I take that point, I'm going to convert to the about symbol, estimated. All right, now we can take our slope and what else? Anthony, what else would I take? I don't have a y-intercept, so what can I take not given a y-intercept, Anthony? I have the slope. I need the slope and a point. Okay, so we're going to take a slope and either point. Now, personally, I'd be using what? Point slope, but of course this is not. So I'm going to take my point. They're going to choose this one, 50, 10, and I'm going to substitute it in. How's it going to read if I substitute the point in, Liam?
10 is approximately
Equal to?
point 0.0110
0 and 1/10 times
times 50
plus b.
plus b.
And then I simplify, and I subtract, and I get my b. And so, Billy, what do I do at this point?
You have to substitute it into y equals mx plus b.
And so the equation is?
Y is about 0.1x plus 5.
Plus 5. Perfect. Now, what this has done is it's taken real-life data and created an equation so we can hopefully predict any size brain. Does that make sense? We're predicting any size brain. Now, I'm going to remind you, Elijah's answer and Lilith's answer may be different depending on the points they chose. Questions? All right, let's move on. Here is my actual line. The only way you can get the actual is if you are using a graphing calculator. For tonight, you may not use the graphing calculator to write the equation. You may use a calculator for the math. Like if you have to divide, 1 2/10 by 20. You can use a calculator for that. But if you happen to know how to do this on a calculator, I don't want you to do that. There's plenty of time for that. That won't stick to you unless you've done this manually a couple times. I need you to do it manually, and there's only one that you really have to do. Yeah.
That's the actual one. Why is it still about, like the about side?
Because there's no way to actually, it's not going to be an exact pattern. Aren't we definitely like your brain size and my brain size may be slightly off. It's not going to be an exact science. We're only creating this equation so we can predict future, or we can make predictions about other species. Does that make sense? It's estimated. Every chimp, if we go back to our data, but that's probably as accurate as you can get because they're doing it in every pig is not going to weigh exactly 180 for their brain. And they're not going to live exactly. My mother and your mother are not going to live exactly the same amount of time. Does that make sense? Yay or nay? I hate that line of light that's in your face. Isn't that bugging you? Okay, so let's go through and quickly summarize some things. We're going to find 2 points. We're going to find the slope. then we're going to use slope and a point to write the equation. All right, let's look at this. Is this a linear trend?
No.
Okay, so we can't write the equation for that. Okay, what about B?
Yes.
No, it's not a linear trend. It's not making a line. That is not a line. It's a blob.
Oh.
Okay. What about C?
Yes.
Okay, is it a positive correlation or a negative correlation? Negative, because it's starting high and decreasing. What about C? Oh, sorry, D. No, not a linear trend. What about E? Okay. What kind of correlation? Okay. And what about F? Okay. So it is, we can try to, it might not be a function, right? Because it doesn't follow the rules. It's a vertical line. But it has a linear trend. And I don't know that we would even say if it's a positive, it wouldn't be a positive or negative. Okay, so some things to remember. Please jot these down. When you're looking for your line of best fit, don't mess with the outliers. Our outliers are going to be ignored. Okay? The line does not have to go through any 2 points. We want to make a line that goes through the middle of the data. You want an equal number of points. Okay, put it up here. Stop going down there. Okay, so now we have to remember equal number of points above and below the line. Questions? You guys got to write quickly right now. We have a lot to do today. Okay, is this going to be the best placement for the line? Okay. Is this going to be the best placement for the line? Okay. Is this going to be the best placement? So we want to kind of go through the middle. Notice I've got 1, 2, 3, 4. I've got 1, 2, 3, 4. 4 below it, 4 above it, going through the middle of the data. Okay? This is going to be very important here. When you choose your points, look what happens when I choose points that are close together. Let's say I choose those 2 points. Okay? Look at the slope of the line. How much does that change the slope of the data? So you want to pick your points further apart. The points you pick, notice how they're choosing 2 points that are not on the line, that are not part of the data. You can do that. You can pick 2 points on the line if they end at 2 corners. Or you could pick 2 points from the data. You can choose, you want to though pick lines that are spread sufficiently apart so that your slope, you see how they're picking this one and this one. I probably would have chosen this and this. I would choose 2 points from the table that are sufficiently spread apart. That's the best choice I would make. But you're not necessarily tied to it. If you draw your line, you can pick any 2 points on that line or 2 points in the data. But make sure they're spread far apart so that your slope is accurate enough. Yes?
What's the minimum sufficient distance?
There's no minimum sufficient. This is not a science. Well, it is, but... you want to pick them further apart. Try and pick the furthest ones that will give you the data. Look at how my slope slightly changes here. As opposed to this one, when they were close, look how much it changes. Does that make sense? Okay. Brandon, question.
Yeah, I was just gonna ask, is there a way to get it even closer?
On the graphing calculator. And we're going to spend a day doing that. We will spend a day doing that. That's why I want you bringing your student journals. So I will show you how to do that on the graphing calculator. Okay. Now, find the equation of the line for best fit. This is a great example of how they might use real live data. It's a very interesting topic. SUV vehicles. In the 90s, that was the it car to have. Everybody was driving the Expeditions, the Suburbans, these big SUV vehicles. If I plot the data, when I plot it, basically, if I'm a car manufacturer, I can basically try to predict how many I'm going to need for the year 2001. Does that make sense? So, because car manufacturers don't make the cars as you get to the lot. They've got to be made well ahead of time. They have to hire the manpower and get the parts and the metal, and so they've got to know how many SUVs they're gonna make that following year, so that they don't lose money and that they gain money, that they get maximum profit. So can we predict based on this? What would you guys predict? I want to hear from somebody I haven't heard from today. Okay, Josh?
I'd say about 3.6 million.
3.6 million. So if I continued this line, we know that it might probably hit about here. He said about 3.6 million. So we'd want to get more exact than just looking at it. And so again, we'd take 2 points. Any 2 points, preferably 2 that are spread far away. Find a slope. And then write the equation of the line. Again, I would probably use point slope. Okay, questions on I understand how to create a line of best fit. No, thumbs up, I understand. Thumbs down, I don't. All right. It's looking pretty good, I think. Okay, is this in the middle?
Yeah.
Okay. Okay, so let's go through, and what part's confusing for you, Colin?
I mean, I understand how you would pick up the line and how you would make the line in the first place. I'm just a little bit confused on when you want to...
Pick the points?
No, like past that. Like when you're doing the slope formula.
Right, that's picking the points. That's for your slope. So, if I notice on the line, you will see I'm picking 2 points that are far away from each other. Okay? They can be on the line. It could be like I could go to the data table. Let's look here. I could take like this one and this one right here. I could pick out of the table actual data points. You just want to make sure that the 2 you're picking, one is not an outlier. Okay? As long as you could actually take 2 points there. But you have to know, Colin, the equation you get may be different than what Billy gets. Because he's not going to choose exactly the same thing as you unless you're doing your homework together. Okay? Which in this case, it's not a bad thing to do your homework with somebody else. Do you understand what to do past that?
That's where
So you use the slope formula. Do you understand how to take the 2 points and plug it into slope? Now, if that's my slope, I'm going to I personally, in writing the equation, what do I do once I have a slope?
once you have a slope, then you would plug it into slope, but they're going to plug it into slope.
Slope formula is this.
No, the slope point. No.
Point slope formula. You need to flashcard that and know those names. So they did it to y equals mx plus b, which is slope intercept. I would probably use point slope, and I choose either point, 1999, 3, and I'm going to do my y minus y1 equals m times x minus x1. Y minus 3 equals 0.271 times x minus 1999. And I'm going to just simplify it. Y minus 3 equals, at this point, I would use a calculator. The calculator is okay because I don't want you to sit there and waste your time doing 271 thousandths times 1999. So my slope is going to be 0 and 271 thousandths x minus, oops, sorry. And I'm getting 541 or 500, about 542. And then I add 3. I'm adding 3. I really got a decimal. Y equals 271 minus, I'm actually subtracting 542 minus 3 is about 538, 539. Okay. Is this making any sense to you, Colin?
Yes.
Okay, check back to the video if you don't get it. What did I say, 539? I estimated up. You can also, like, I probably would have done this too. If I was taking this, I kind of would have, I know that that was very close to 2,000. So if I didn't have a calculator, I would do times 2,000. But you can use a calculator, okay? Just don't jump ahead and do it on a graphing calculator, as in use the function of the graphing calculator to write lines of best fit. That's a lesson ahead. All right, questions. Let's look at our homework tonight. So if we want to predict a future year, any year, and it's moving at the same thing, again, remember my x is 2,000. So let's say I want to know how many to order for 2004, or what my sales is going to be. I would just plug in 2004 and I could get my estimated amount of vehicles I'm going to be selling. If the time. Now let's talk about this. Is this a real life situation right now? Yeah. It was. Does this go with the today's current data? Why? Why are people not buying SUV vehicles, Suburbans, Expeditions, and all that? Ellie? Why? Why did they stop making them? If they make money on them, do you think this world is gonna what is the reason they stopped making them? What? Okay. How about Aiden?
Stop being popular.
Why are they why are they no longer popular? There has to be a purpose. They're popular. Look, they create the trend. But why do people stop buying? Julian?
Because they use too much gas.
Gas. What happened to gas prices? Yeah. Gas prices go up. Big car sales go down. The money will drive your market. So if people don't, who wants to spend $100 to fill your tank of gas and only get minimum amount of mileage? That's why people stopped buying them. They didn't have the money. Imagine a 16-year-old filling up a Suburban, with 2 tanks. Doesn't your car have 2 tanks? Okay, it's probably over $100 to fill it up, and you probably get maybe 8, how many miles? Maybe 10 miles per gallon. At most, probably less. Oh, well, no, you guys are diesel. The gas is cheaper. But gas got very expensive, and that's why they stopped making these. Money really drives the market. Yeah.
But are we going to do, if we kept this, the years going, it would go...
For the homework, we are basically, let's look at the kinds of questions you'll be looking at. All right, we're starting with this. This is basically what they want to know. How can you use a scatter plot and a line of best fit to make conclusions about data? The first kind of question we're going to see, you'll have like, oh wait, this isn't it, sorry. Here we go. You'll see something and they'll start asking you questions. Here's a scatter plot relating sugar in grams to calories. Okay, you're going to have to answer these types of questions. How many calories are in a smoothie that contain 56 grams of sugar? How do we figure that out? Brandon?
You find the point on the line that has 56 grams.
56. So here's 54, here's 58. I'm going to 56 and I'm just coming straight up. Questions? Okay, now, this time they're asking us how much sugar is in something with 320 calories. So I now go to 320 calories and then I go across until I see a point. And that is 70. Is this making sense? Thumbs up, thumbs down. Yeah.
What if there's 2 points? Like at the same.
I'm asking you, can you read this? This is where I'm at right now. Let me get to the homework, okay? Because we're short on time. We haven't gone through last night's homework. Are you able to tell me if it's positive, negative, or no correlation? Okay? Now, the next one says make the scatter plot of the data. Remember, your scale doesn't have to be the same for the X and the Y. All you're doing is making the scatter plot and looking at the graph and telling what kind of correlation it has. Positive, negative, or no correlation. Questions? I understand, I don't. Thumbs. Mark? Okay. Next one. Now, you're going to finally make one line of best fit. They're going to give you data. There's only one of these. Okay? You're going to make the graph. You're going to plot the data. You have to take 2 points and do what? Find the what? Slope. Then use point slope, a point in the slope, and write the equation. And that's basically it for tonight's homework. You feel like, now look at how they're giving you, this is another one where they're just giving it to you in a paragraph. But they're giving you data points. It's the same thing, it's just not given to you in a... Now, the hardest part is going to be interpreting the slope. And we will talk more about that tomorrow. Interpreting the slope means, what does the slope mean? When it says 0 and 1/10 x, what is it representing? What is it representing? You know, that's basically, what does that mean? I want you to try and attempt that tonight. Yes, Brandon, now.
Oh no, I was going to answer the question.
Okay, so in that one, let's talk about that particular problem, which was the brain. I didn't mean to close it. Oh, here it is. Let's go back to... Let's go to... This is a long video. It's going to take a long time.
The brain is way over, isn't it? Yeah, the brain is. Yes, like the second one or something.
Okay, so we're looking at this one here, and we get the, we get this, and we found the, we found our slope. What does that 1/10 represent? Think about what is y1 minus yx really representing. What? Brandon, what were you going to say?
Well, that for like every 1 y, there's that flash.
What did the y's, in terms of the, what was the topic about?
Wasn't it the
The y's represented the lifespan, right? Wasn't this lifespan? And this represented what? The brain weight? Now, although we're using 0.1 as my m, what does this, let's convert that to a fraction. What fraction would that be? Yes.
1/10.
So now, make sense of that. If this is lifespan, and this is brain weight, Tristan.
Your brain weight is 10 times your lifespan.
Perfect. Perfectly said. That's what that means. Or for every 10 grams, you get 1 year of life. Every 10 grams of brain weight, there's 1 year of life. Does that make sense? That's interpreting the slope. All right. Long